Hello again and welcome to the using Git with GitHub module, and this is the GitHub desktop version of that. So we're not going to use the command line in this video. We're going to work primarily with the nice graphical interface of GitHub desktop. So first things first is we need to have a repository to work in. If you don't have a repository, now of course as far as this training is concerned, we're going to be working in our GitHub training repository, but I will show you these steps so that for your own projects or classes or what have you, you're familiar with kind of what you'll be prompted to do when creating a repository. So you click New Repository, and you can give it a name, like in this case, I would have my example repository. And you can optionally give it a description. I generally don't. I find that's just extra for me to think about that I choose not to. And I think READMEs tend to accomplish that better. And I'm sure there are ways to use both, but I never have that much to say about my projects, so I just initialize with a README. Now, READMEs, you may notice, are how we work in this repository. READMEs render a README in a given directory will render when that directory is displayed on the home page. So like for a README in your main directory, which is what we're doing right now, a README for your whole repository will display automatically on the home page of your repository. So it's really nice for things like setup instructions, tips and tricks, hints, ways to run news announcements about your project, anything like that. All that's good on the README because it'll pop up on the home screen automatically. Now, when it's time to add a git ignore, these are just some of the potential templates for a git ignore, and you can find many more git ignore templates around the interwebs. If you choose not to create a git ignore here, you can simply add a file called .gitignore later and fill that with whatever you want to do. So what a git ignore does is it basically tells Git to ignore certain types of files, whether it's by name or by extension or by directory that it's located in, and this prevents extraneous things from making it into your repository. Things like compiled code that you simply don't need because it gets remade every single time the project is built. We don't need to waste that space, and it could also cause merge conflicts. So git ignores are highly recommended for the language or framework of your choice. So there are git ignores for Java, there's git ignores for C++, and there's git ignores for Android if you're working in Android Studio. There's tons on here, and of course look around for your own if you're working on something different that's not supplied here. Now, as for a license, you might not know this, but technically, even though you have a public repository, your code on GitHub is not necessarily open source unless you choose a license that specifically says it is. Like, I like to use the GNU General Public License version 3 that says my code is open source and these are the terms for using it. There are several different options, and GitHub has a really nice picker that is mentioned in the README for this assignment. There's a link to the how to choose a license page, and GitHub has a really nice page set up for that. So I recommend you definitely check that out if you're thinking about picking a license to add on all your projects. Also, you can check out things like the unlicensed academic, which is also linked in the README, that is specifically designed for students. And so then the last thing that we have to choose after we've selected a license is whether we want public or private. Generally, I mean, if there's no reason to keep your code private, I tend to keep mine public because I want to be able to collaborate with friends. I want people to be able to see what I'm up to. Private, though, generally costs money. If you sign up for the Student Developer Pack in Module 1, then you can have private repositories for free. And that's more for stuff like personal projects that you're trying something new, maybe like a class assignment that you want to make sure that doesn't accidentally get copied by another student, something like that. So we have covered creating a repo. Let's go to the repo we're going to be using for this assignment. Once again, it's the GitHub training repo. So we're going to go over cloning this. So like we did in Module 1, we can edit this from the web interface, but that's not necessarily the best way to edit this all the time, depending on what we're doing, especially if it's a big project that has like an IDE project. We obviously are not able to launch our IDE right here in the web interface, so we can click our clone or download link and say open in desktop. So now you can see GitHub training is my current repository. You may have an extra couple of steps here to choose where to save it. The default location is just fine. The default location is a subdirectory of documents called GitHub. So this is actually saved in documents/GitHub, and that's where GitHub training is. And this is the interface for GitHub desktop. Now, we can create a working branch several different ways. The way that we're going to do it is go to branch, new branch. Notice we need to give a name, so we could call this CCanon 94 Module 2, because we're going to be working on our Module 2 submission. And we should create a branch based on master. Now, it's possible that maybe you have some changes on another branch that you need in order to do this branch. Like if you've had Dr. Bryant's Comp 167 class, when he works on the major programs, you have to do each level on a different branch. Well, a lot of times you start working on the next level before the one before it is merged. So for instance, if I'm starting on level 3, but my level 2 code isn't on master yet, I would create a branch based on level 2 so that I have all those changes that I need. I wouldn't want to do it based on master because that doesn't have everything I need to move forward to level 3. But most of the time, you'll be creating a branch based on master, and that's what we'll be doing here today. You want to go ahead and do that. So making, saving, and tracking changes is real simple, especially if you follow the installation instructions and you have installed Atom. We can choose repository and open this in Atom, and that will pull up an Atom text editor for us. Where we can add a submission to CCanon 94 like the exercise instructions will eventually tell you to do. So because these are both GitHub products, it's real easy to go from GitHub desktop, choose repository, open in Atom. We can also view it on GitHub, show it in Finder, or on a Windows PC that would be show in Explorer, and that just opens the file system, and we can open it in Terminal. So those are some nifty ways that we can get to that. Now in GitHub desktop, as far as tracking and adding and staging our changes, those are steps that we have to worry about on the command line, but on GitHub desktop, they get saved automatically. So you can see when I create a new file called module 2/getquiz.md, those changes automatically come up over here. There's nothing I have to do. They're already checked. I can unstage them by unchecking, but obviously I want to keep those staged. So now let's talk about committing. We've created and staged some changes, and now we need to take those changes, group them into a commit, and commit them to Git, like we have been discussing. So the way that we'll do this on GitHub desktop is just give a quick summary. Now a commit message should be simple and concise. It should be like 50 characters or less, and it should say the one change that you made. If you can't boil what you did down to just the 50 characters, you probably have done too many things between commits and should consider breaking that commit up into multiple commits. So I'm going to say create getquiz.md, because that's what I did. I can go ahead and commit that to module 2, and my commit has been done. Now in history, I can see create getquiz.md, which is awesome. Notice I use the imperative voice. You don't use past tense because I'm still on my CCanon 94 Module 2 branch right now. I'm not on master. And remember, master is the authoritative copy of this repository. So really, as far as my real project is concerned, I haven't actually done this yet. So I just say what this will do. It will create this getquiz.md, and that's one of those things that it's not super important to stress about, but it is a good thing to learn because it really shows a slightly higher level understanding of Git and how Git works, and that's what we're really trying to get across in this training. So now let's talk about pushing and pulling. Now is a good time to push because I just made a change on a new branch. Notice right now this says publish, which means this branch doesn't exist on GitHub yet, and this is the same thing as a push. I can also go from repository and push. Could click there, could go to repository push, either way, and now that push has been made. Now I can choose repository pull, but of course I'm already up to date because I just added all my changes on there. So those are the ways that you push and you pull. What a push does is it takes all your local commits and it pushes them up to your remote, which is, as the README for this notes, is GitHub. GitHub is acting as our remote here. And then a pull takes any changes that your remote has down to your local machine, our laptop or our desktop that we're working on. So pushing and pulling is how we keep these things up to date, and we have to do them manually and we have to do them often. Anytime that you finish working at your computer and you stand up to leave, you should push. Anytime that you sit down on a new computer before you start working, you should pull, just in case something's been changed. You definitely don't ever want to walk away, close your laptop, walk away from a desktop without pushing, because anything can happen to those hardware devices. And if something were to happen where you lose your files, there's just no way to get them back. Versus if you've pushed them and something happens to your physical device, it's fine, it's on GitHub, nothing to worry about. So, updating branches from master. In my previous example, where there were some changes on level 2 there were changes on level 2 that we needed to work on level 3, right? Well, it's possible that level 2 keeps advancing after level 3 has been branched, right? So now once level 2 is merged into master, we have updates on master now that level 3 doesn't have. Well, let's say that's the case. It's real simple. We check out master, and we fetch the origin. And then we check out our working branch, and we choose branch, update from default branch. And if there were any changes, they would be pulled right in. So now I have the most up-to-date things from master on module 2. It's also just like our example in module 1. All those green commits, the green branch needed to get the input from yellow before it could be merged into master. So that's all we did. We went to master, we got the most up-to-date version, we went to our working branch, and we merged master right on in. And that is all you need to know to work with Git on the desktop getting started. So now it's time to do the exercise listed at the bottom of this README. You can see the README for that information, and you should be answering just a couple quick questions to make sure you get a basic grasp on this and make sure we have a chance to discuss it if you're not quite catching it right here in the quiz.md file. So thanks so much for joining in for the GitHub desktop introduction to using Git with GitHub. Hope you have a good grasp on it now, and look forward to seeing you in the next module.